Welcome back to my channel. I hope you are doing well. If you watch my first video, you will remember that I mentioned I will be designing the elevator tower of Rockwell factory in this series. Well, today's video is a continuation of that, and I will be showing you the next step in the design process. In previous video, if you watched my video, I talked about using Rhinoceros for some parts of the project. In today's video, I will be using Rhino, and I will explain why it is useful tool for kind of project. I will start to showing Autodesk Inventor model. As you know, I mentioned in the first video, we will continue work on in elevator tower Rockwell factory. In this model we will continue, and today the first thing I will convert to this model to the STP model. How I will do: file, export, CAD format, and from this I don't want to do this because it is taking time, and my computer is freezing. That is why I export before I start the video. So you will just convert from here STP model or IGES model, because Rhino is opening to STP model and IGES model also. So after you convert, we will open to this Rhino model. I converted also to this STP model to the Rhino model. I open. Maybe you might be wondering why I am switching from Inventor to Rhino. The reason is simple. Compared to the Inventor, Rhino allows the faster and more precise measurements. As you can see, before I start to video, I just make it all of them, because I don't want video take 1 hour, 2 hour. Just I will show some simple example like here. As you see, if your snap is open, you just go here. You can see this measurement and this measurement. You see. So I made it all of the measurement before. Okay, all X and here Y and Z is also here. So I make it all of them, and we will transfer this data to the SAP2000. As I said before, Rhino allows for faster and more precise measurement, which is crucial when dealing with detailed design in like this one. Rhino is the more flexible when it comes to taking the measurement. So I will use Rhino in every project, I think. And by the way, I want to remind you that this video is not a full tutorial video. Maybe you can say, Engin, you are passing to faster, but I should say to you, this is not full tutorial or educational video on how to use Rhino or Inventor. Instead, the goal here is to show you how we as engineers can use different software tools to achieve our objectives in design project. Okay, the purpose of this video is give you a look at the practical application of these programs in real world scenarios, not to dive deep into their technical functionalities. Okay, just I wanted to explain this to you. Now we have got our basic measurements and access from the Rhino. Let's switch the gears and open the SAP 2000 and input to this details to the software. Okay, I already opened because, as I said before, I don't want my video take too long time. So you will make it a new model grid only and make it okay. Okay, you will see the main page of the SAP 2000. If you want, I can explain where we will use. Firstly, we will use edit, replicate, replicates. With replicates we will copy, and edit lines we will divide lines or join the lines. In the first step we will do this. And the materials, we will define the materials and section properties. Then draw many, we will draw the cable. Okay, maybe we will use the points today. If we can have a time, we can assign some joint or frame. I don't know, maybe we will not have this much of time. As you can see, now I am inside to the SAP 2000 and we are ready to defining the grid. Okay, you will make right click, okay, edit data, modify and show system. Okay, here we go. I just want to close here. One of them is okay. I just want to go for X lines. It is important to make sure that these lines properly, because any misalignments at this stage can affect all structure, and attention these details. Okay, 2200 from here to here. Yeah, data modify. As you can see, 1 2 3 4 and AB is let's make the AB from here 2500 AB. So I will delete this, the other. Let's check it if it is okay or not. You see, just two axes here. Edit, create data, modify, and I will go for here. I will have a look from here. Maybe I can make first axe here, second, third and 4. 2200. Sorry. Other 1045. Let's go. So here is stairs and the other side is bucket elevator, and I will go for Z dimensions. Okay, Z dimensions is the very, we have a lot of work here. 2 3 20. Okay, what we are doing anyway, we can make, it will take time. 2320 5070 5070 8070 I think 11070. It means, so if you want to add, you can add 11070. After this we need to be careful. We need to be careful because which one is the next? 11670. Okay, one one 670. And I want to remind you, as you know, we are making a structural analysis. So in the structural analysis, the manufacturer company is manufacturing profiles at much 12 meter high. So our building is 20 meters, so I will divide it by 2, 20 and 8. So I will give a one more height as a 12 meter. Okay, 6, sorry, I will write the big letter. 6, 7, 8, 9, 10, 11. Okay, I write the 12 meter. So we keep continue. 12400. $13,295. 13,295. $15,795. 15,795. $18,795. $20,045. $20,045. I will write the grid ID. Yes. Yes, we will say okay. And again okay. And you see, now that all our axes are in the place, we can see how they interact with each other, giving us a clear layout of the structure in the 3D view. You see? Yes. Okay. I will stop video. I will stop video here. Thank you for watching. I will keep continue from column and beam and diagonals. See you on the next video. Okay, thank you very much.